Okay, this is another C2 topic called factor, and remainder theorem. Okay, I'm going to start off with factor and remainder theorem, and I wanted to show you a little bit about where this idea comes from. So we're going to do a little bit of theory first, and then I'm going to show you how to set it out in exam-style questions. So here comes a little bit of theory. 13 divided by 3. Okay, 13 divided by 3 is 4, remainder 1. And would you guys be happy that 13 divided by 3 is 4, remainder 1? I could write it in exactly the same way by writing that 13 comes from 3 times 4. So I've times them up, that gives me 12. And the remainder then gets added on. Okay, now, what we've got in front of us on the next one is we have a cubic polynomial. A polynomial is just an expression with x's, divided by a linear polynomial. And it's linear because the x is to the power of 1. Okay, so if I did exactly the same thing, I did, instead of 13 divided by 3 gives me 4, I said my cubic divided by my linear gives me a quadratic. Now, I don't know, obviously, why does that work? Okay, because x cubed divided by x gives me a quadratic, okay? X cubed divided by x is x squared. I don't know what the quadratic is, so I'm just going to call it a quadratic. And then, of course, I will be left with a remainder, and I don't know what the remainder is, so I'm just going to call the remainder a question mark. Right, if we write exactly the same statement out as we wrote up here, what we're going to end up with is 2x cubed minus 4x plus 1, that's the same as my 13 on the top, all right, that's the same as the top, equals, I did 3 times 4, so I'm going to do x minus 2 times my quadratic. I don't know what my quadratic is. And then what I did was I plussed on the remainder. Now, I don't know what my remainder is, so I'm just going to write remainder, and I'm going to put a question mark like so. Now, in remainder theorem, this is very clever. What they're going to ask you to do is they're going to ask you to actually find the remainder. Now, what are they actually asking us to? Well, this one's easy, isn't it? We can just see that the remainder is 1. But they're going to ask us to find the remainder when we do polynomials, in this case a cubic, divided by other polynomials, in this case a linear. And they're going to ask me what is the remainder. Right, it's a very, very clever trick. What we do is we let x equal 2. Why would we do that? We're basically letting it knock the bottom out, or you're letting the bottom equal 0. Now, if you actually let x equal 2, what you'll end up doing in this side is you'll end up having 2 minus 2. Now, 2 minus 2 is nothing, and you'll end up with nothing times the quadratic plus the remainder. Okay, nothing times the quadratic is just nothing, and then you'll end up with just the remainder on the right-hand side. So nothing times nothing plus the remainder, well, we can get rid of the nothing, can't we? And we'll just be left with the remainder. Now, how did we do this? We did this by letting x equal 2. So what we're going to have to do is feed a 2 into here. Okay, let me rub him out to get him out of the way. So when x is 2, we're going to end up with 2 lots of 2 cubed minus 4 lots of 2 plus 1. That's a 2 cubed there. Okay, 2 cubed is 8. 8 times 2 is 16. Minus 4 times 2 is minus 8. Plus 1. 16 take away 8 is 8. 8 plus 1. So I reckon the remainder is 9. So when I do 2x cubed, let's rub him out. When I do blah, 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 blah. When I do 2x cubed minus 4x plus 1, and I divide it by x minus 2, my remainder is coming out as 9. Clever. Okay, we're going to do another one informally, and then on the next slide I'm going to show you how I want you to set it out in the exam. So the question will ask you to find the remainder when this cubic is divided by this linear, and it's just as easy as this. We let x equal something that will knock the bracket out, so we're going to let x equal minus 1, and we are going to shove it into the top. So the remainder comes from minus 1 cubed plus minus 1 squared plus minus 1 plus 4. So the remainder is minus 1. Minus 1 squared is plus 1. Minus 1 plus 4. I reckon it's coming to 3. Bingo. Okay, I'm going to do one where I show you exactly how I want you to set it out in the exam. Right, so this is how we're going to write it from now on. Find the remainder when this cubic here is divided by this linear. So the first thing that we're going to do is we're going to write out the cubic as f of x. X cubed plus 2x to the 5 plus 6x. Now, if it's being divided by x plus 1 and I'm being asked to find the remainder is found by me feeding in anything that will knock that x plus 1 out or make it 0. So what I'm going to do is I'm going to use x equals minus 1. And the remainder, now if I can either write let x equal minus 1, or it's better to use the function notation and say I'm just going to feed a minus 1 into my f of x. So the remainder is found by f of minus 1. So it's going to be minus 1 cubed plus 2 lots of minus 1 to the 5 plus 6 lots of minus 1. Okay, the next line is important that we fill the numbers in. Don't just bung that straight in your calculator. So this next line needs to be seen. Minus 1 cubed is minus 1. Minus 1 to the 5 is, now that's minus 1, isn't it? So that gives me minus 2. And 6 lots of minus 1 is minus 6. So I reckon that that remainder, 6, 7, 8, 9, is minus 9. That's my answer. Okay, you have a go at the next one. In fact, the next one's got an error. It should be minus 2x cubed. All right, that's what it looks like in your pack. Okay, you have a go. Pause the video, and then I'll go through the answer. Okay, here comes the answer. Find the remainder when this is divided. Right, first thing we're going to do is we're going to write out f of x equals x to the 4 minus 2x cubed plus 4x plus 5, and we're going to divide it. So how are we going to find this remainder when it's divided by x minus 2? We need to let x equal, so we can either write out let x equal 2, but it would be better or neater to just pop it in as f of 2. So 2 to the 4 minus 2 times 2 cubed plus 4 lots of 2 plus 5. Don't miss out the next line. The next line is important. 2 to the 4 is 16. Then 2 cubed times 2 is 16 plus 8 plus 5. So I reckon 8 plus 5, the remainder is coming out as 13. Okay, factor theorem is just a little tweaky bit of the remainder theorem. Now, if we start off with something we know, so let's just say I did 20 divided by 5, you guys would all say, yeah, it's 4. Now, it's 4 and there is no remainder. Bing, bing, bing. The remainder is actually 0, isn't it? 20 divided by 5 is 4. So what we would say is we would say that 5 is a factor of 20. Okay, so if they talk to you about the factor theorem, all you need to know about the factor theorem is it's just when the remainder is 0. That's it. That's all the factor theorem is. The remainder is 0. So we just do it in exactly the same way that we did it before. I'm going to do one and then you guys can do the second one. So the question would say, show that x plus 2 is a factor of this. So we start off by saying, here's the function. F of x is x cubed plus 3x squared plus 5x plus 6. And they're asking me to show something as a factor. So what I'm going to do is I'm going to find the remainder when it's divided by x plus 2. Now, if it's divided by x plus 2, I'm going to let x equal minus 2. So the remainder is found by f of minus 2. So we're going to feed a minus 2 in. Minus 2 cubed plus 3 lots of minus 2 squared plus 5 lots of minus 2 plus 6. It's important that we fill that bit in. So the remainder is minus 2 cubed is minus 8. Minus 2 squared is 4. 4 times 3 is plus 12. Minus 10 plus 6. So I reckon the remainder is coming to... it's coming to minus 8 plus, it's coming to 0, which is exactly what we thought. We were expecting it to come to 0 because we've been told it's a factor. Now, on these questions, the most important thing you guys do is you give a final statement. It's asked for a show, and if it says show, you must write the following. That stands for therefore. Therefore, x plus 2 is a factor. And if you don't write that last line, they will knock you a mark. Okay, you guys try the next one and pause the video, have a little try, and then I'll go through the answer. Okay, here comes the answer. Right, show that x minus 3 is a factor. So first thing we do is we write out let f of x, don't need to write the word let, f of x equal x cubed minus 3x squared plus 4x minus 12. Okay, we're going to find the remainder. So what we're going to do is we're going to let x equal 3. So we're going to let x equals 3, but we're going to write it f3. Okay, 3 cubed minus 3 lots of 3 squared plus 4 lots of 3 minus 12. Let's work that out. 27. 3 squared is 27 plus 12 minus 12, and we can see it's 0. And we're not going to lose a mark because we're going to write, therefore, x minus 3 is a factor.